Hello. Good morning, everyone. Today, our group will present our assignment for computer architect course. Our team members are Tsai Junyan, Wu Xiaojing, and Wang Junsheng. Let's start with part 1. Our first task was to convert a math expression into cosmic notation. The expression is a plus b times c minus d per e. To solve this, we use the start method. After following the rules, the final result is ABCD minus times E per E plus. That's all for me. Now I pass to my member.
Okay, thank you for Junyuan. And now for my part, start diagram. Next, let's look at the start diagram. The expression here is P minus Q plus R times X over T. In this problem, parentheses ensure that Q plus R happens first, then multiplication and division happen before subtraction because they are stronger operators. We push operators onto the start and pop them up when needed. The final postfix expression becomes PQR plus X times T over minus. For the zero address machine instruction, first is the zero address machine. This type of machine does not use address in the instruction itself. Instead, it uses a start for the expression P minus Q plus R times X over T. We simply push operands like P, Q, and R onto the start when we need to calculate, like adding Q and R, we just use the instruction add. The machine automatically takes the top two numbers, add them, and puts the result back. Finally, we pop the result into Z. That's all my part. And I want to pass to next member, Xiaojing.
All right, thank you, Jason, for his presenting. So my part is one address machine instruction. So this machine use something called a accumulator, which is AC. Is like a calculator that holds one number at one at a time. For expression, we use commands like load to put a number into accumulator, install to save the result into memory. For example, to subtract B, we must write sub B. This means current accumulated value minus B. This format is simple but requires temporary storage to complete the math. Okay, for the next part, to address machine instruction. So here, each instruction has two parts. One source and one destination. So the trick is that the destination also stores the result, which overrides the old data. For the expression, z equals to a plus b times c minus d. So we use the instructions like move z and a to move the data and add z b to add the b to add b to z. This reduces the need for extra temporary storage compared to the one address machine. So the next part, so finally, the last part, we have the three address machine. This is the most flexible format. It uses three address to two for the input numbers and one for the result. For example, in the expression z equals to a times b, over C minus D times E. We can write div divide, which is divide div T1 B C. This means divide B by C and save it in T1. This is great because it does not override our original data. So I will give the last part, which is the conclusion to our team leader, Tai Junior.
In conclusion, our presentation of machine instruction and state operation, we hope our explanation was clear. Thank you for listening.